my name is Peter, and in this lesson, we're gonna talk about introduction to fractions. First, we're gonna take out the overview of today. First, we're gonna look at parts of fractions, then different operations and rules for fraction, and then we're gonna look at practice problems. And also, as usual, we have a challenge problem at the end and a summary for all the rules and operations we've seen today. First, what are fractions? The definition of fraction is a fraction represents a part of the whole thing, which is basically just dividing. The denominator we see here is the bottom number representing the total number of the equal parts. The example here we see the denominator is 57. It's the bottom half of the fraction, which is the number of parts in the whole, which is the whole total number we have. The numerator is the upper part or the top half of the fraction. This is representing how many parts we have, which is basically how many parts we have in the total parts. The fraction is the whole thing here, 20 over 57. The line separates that numerator and denominator. It doesn't have a name, but we can view this as a dividing symbol, so we can rewrite this fraction into 20 divided by 57. So this is basically the same thing that this represents. Example 3 over 7 means 3 out of 4 equal parts. In this case, 4 is the denominator, so 4 is the total parts we have, and 3 is the numerator, so 3 is how many parts we have out of the total parts. Let's take a look at the visualization here. So when we're talking about fractions, we usually use pizzas or pies as visualization for you to better understand. Here, the whole is 1 out of 1. So in here we have total 1 slice, and we're taking 1 slice. So this is 1 over 1. So this will basically equals to 1. 1 half. Here we have total of 2 slices, and we're taking 1 slice. So this is 1 half here. 1/3. We have 3 slices in total, and we're taking 1 slice. 1/4, 1/6, 1/8. Similar to the earlier examples we talked about. Next, let's look at the types of fraction we have today. So there are three main types of fraction. First, proper fraction, which the numerator is less than the denominator. As we can see in this example here, 3 is the numerator and 5 is the denominator. So in this case, 3 is less than 5. This is a type of proper fraction. Improper fraction, the numerator is greater or equal to the denominator. In this example, we see 5 is the numerator and 3 is the denominator. So in this case, 5 is bigger than 3. So this is an improper fraction. Improper fraction can also be when the numerator is equal to the denominator, as we see in the pizza example here. 1 over 1, the numerator is equal to the denominator. So this will just simply be 1. In any case, any number when the numerator is equal to the denominator, the result is always 1. Mixed numbers. A whole number combined with a fraction is a mixed number. As we see in this example here, 2 to 3 over 5 is a mixed fraction. So in mixed fraction, we have a whole number in front of the fraction, and the numerator is less than the denominator. So we will talk about how to simplify or convert this into improper fraction or in the later slides. Okay, let's take a look at the first topic here, converting mixed numbers to improper fractions. Steps. There are 3 steps here. First, you multiply the whole number in front of it to the denominator, and you add the result to the numerator of the fraction and write the sum over the original denominator. What does this mean? Let's take a look at this example here. So in this example, you multiply 2 to 4, which is the whole number, to the denominator, and you add to the numerator, which is 1. So 2 multiplied by 4 is 8, and you add 1 is 9. So this will equals to 9 over 4. Let's take a look at some few examples here. First, 3 to 1/3. So we can convert this into improper fraction here. First, you multiply the whole number to the denominator, which is 3 times 7, which is 21. And you add the numerator, which is 1 here, plus 1. And you keep the denominator the same in the question. So in this case, it's 3. So this will just turn out into 22 over 3. 22 over 3 here. In this example here, you multiply the whole number to the denominator and you add to the numerator. So this will just be 7 times 10 plus 9 over 10. You keep the denominator the same again. So this will just equal to 79 over 10. 79 over 10. In this last example here, as usual, we multiply the whole number to the denominator and you add to the numerator. This will just becomes 7 times 4 plus 3 over 4. So this will just becomes 31 over 4. So pretty easy concept here, converting mixed numbers to improper fraction. We'll see how to use this in later operations such as multiplying, basically adding, subtracting. Next, after learning how to convert mixed into improper, now we're going to take a look at how to convert improper fractions to mixed numbers. So there are three steps here. First, divide the numerator by the denominator. The quotient is the whole number. The remainder is the numerator, and the denominator remains the same. So this is basically the opposite of what we just did in the last slides. Let's take a look at what this means. So convert 7 over 4 to a mixed number here. First, you divide the numerator by denominator. So this would be 4 divided by 4, which is just 1. And 4 divided by, so you add the whole number here. The whole number is 1. And the leftover is 3. So it's 1, 3 to the 4th. Let's take a look at 4 examples here. First, 7 over 4. First, you divide the numerator by denominator here. So 7 divided by 4. This is basically the example we just seen. 7 over 4, which will becomes 1. So the new whole number is 1 here. And 7 over 4, we have 3 left. So this is just 3 over 4. Next, 9 over 4. First, we divide the numerator to the denominator. 9 divided by 4, the quotient will be 2. And the leftover will just become 1. So this is 2 and 1 1/4. Number 7 here, 36 over 2. So you divide the numerator by the denominator first. 36 divided by 2. This will just result in the whole number 18. So you just write 18 here. As we talked earlier, you can see this line in the middle as the divide symbol here. Let's take a look at number 8. 37 divided by 2. This will equal the whole number will be 18. And the leftover will be 1. So this will just becomes 1 over 2. So converting proper fraction to mixed numbers is just basically the opposite of we just saw in the last slide. Let's take a look at the first subtracting operation we seen today. In order to multiply exponent with the same base, add the exponents together to get the same base. This is when adding a fraction with the same denominator, you add the numerators here, and you keep the denominators the same. So in this case, 10 is the denominator. The denominator saying you don't have to do any conversion. And you just add the two numerators together. This will be 7 over 10. 1 plus 6 is 7, so it's 7 over 10. Let's take a look at four examples here. The denominator is same, so we add the numerators together. This will be 5. 4 plus 1 is 5, and you keep the denominator, which is 6. This case here, 4 plus the denominator is 8, so we keep it, and we add the numerator. 4 plus 7 will equals to 11. In this case here, 9 is the denominator, numerator. 2 plus 3 is 5. So we keep the denominators the same. Let's take a look at this example here. The denominator is 12. Numerator 10 plus 6 is 16. We can actually simplify this, which we'll talk about later today. Simplifying, which is when simplifying, you just basically divide the numerator and denominator with the least greatest common factor, which we will talk about later today. In this case, it will be 4. So the top number will be 4, and the bottom number will be 3. And we can actually convert this into an improper to mixed number fraction. This will becomes 1/3. Let's take a look at subtracting fractions here. Subtracting fraction with the same denominator. There are 3 steps here. First, subtract the numerators, keep the denominator same, simplify if necessary. So this is basically just the opposite as we did when adding. In this case, you just subtract the numerators instead of adding them. So in this case, we see 12 is the denominator and 10 and 3 is the numerator. So we subtract 10 and 3. This will become 7. This case, 2 and 1 is the numerator, 3 is the denominator. So this will just becomes 1/3. 5, in this case, 7 is the denominator, 5 and 3 is the numerator. So this will just becomes 2/7. The last case we see here, 4 is the denominator and 3 and 2 is the numerator. We subtract them, we will get result in a 1/4. So subtracting fractions with the same denominator, pretty simple, just the opposite we see in the last adding, but we'll get to more complex operations later. Adding and subtracting fraction with the unlike denominator. So there are 3 steps here. First, you find the least common denominator, and second, you convert the fractions, and you add and subtract the fractions as we just seen. So when adding or subtracting fraction with unlike denominators, you want to convert the denominators to the same. So in this case, we see 9 and 3. So so we find the least common denominator. So in this case, we multiply 3 to 9. We multiply 9 to 3, and we multiply 3. So when multiplying the denominator with a number, you have to multiply the number to the numerator 2 in order to get a precise result here. In this case, 3 multiplied by 9 and 2 multiplied by 9. This will just become 27 over 21 minus 18 over 27. We can do the operation we just learned. But in this case, you can actually do a little simpler. We see here 9 and 3, and the least common denominator will be 9. So in this case, you can just multiply 3 by 3. So you can just multiply numbers to each denominator to get them into the same result. So in this case, you multiply 3 by 3, multiply 2 by 3. This will just becomes 9/6, and it can be a little simpler here. Let's take a look at the first example here, 3 and 15. When finding the least common denominator here, we can first just multiply the two denominators, and we can get one answers here. This will becomes 15. And in order to get the denominator here to 15, we must multiply by 5. So we must multiply both the numerator and denominator to 5. 4 times 5 and 3 times 5. This will becomes 20/15. In this case, we have to multiply 3 in order to get to 15. In this, we have to multiply 3 to the numerator 2. In this case, it will result in 6 over 15. This will just becomes 26 over 15. We can actually simplify this. Actually, no, we cannot simplify this. Let's take a look at the next example here. So the denominators 10 and 5, the least common denominator will be 10. In order to get 10, you multiply the denominator to 2 to 5, and you multiply the numerator 2, and this will become 7 over 10 minus 4 over 10. This will just become 3 over 10. Last example here, the least common denominator. When you have trouble finding the least common denominator, you can just simply multiply the denominators together. You multiply the denominator of one fraction to the other fraction. So you result something like 9 times 7 will be 63, and 5 times 7, which is the other denominator to the numerator, will just become 35, and this will become 36. 9 times 2 will be 18. This will result in 53 over 63 here. Okay, so adding, subtracting fraction with unlike denominators, we can just basically apply the rule we just learned here, but we have to convert them to the same denominator first. Let's take a look at the other example, adding, subtracting mixed numbers. So in this case, we have to apply all the rules we saw in earlier slides here. First, you have to convert the mixed number to an improper fraction if necessary. Add and subtract the improper fractions and the whole number separately. And yeah, basically you just do, first you convert it into improper fraction here as in the example here. Then if the denominator is different, you find the least common denominator and convert them with the same denominator. You add them together and you convert it back to a mixed number. But in some question, it requires you to keep it as an improper fraction. So it depends on the question here. Okay, let's take a look at the next 4 example we have today. First, 1.5 plus 1 is 3. The first step here, convert it into improper fractions. In this case, it will be 2 over 3. You multiply the whole number to the denominator. You add to the numerator 2 to the 3. This will be 3 to the 4 over 3. And then next, we're gonna find the least common denominator here. The least common denominator will be 6. Both 6 and both divide 2 and 3. That's what a least common denominator mean. This case, in order to get 3, multiply this 2 by 3. So this will become 9 over 6 plus. In order to get 6 here, you multiply by 2. So this will become 8 over 6. In result, we will get 17 over 6 here. Let's take a look here. This first converted to improper fraction. This will become 3 over 2 plus 5 over 4. Then convert it into with same denominators here. So the least common denominator here will be 4. So you multiply 2 by 2, 3 by 2, 6 over 4 plus 5 over 4. This will become 11 over 4. Next. First convert it into improper fractions. This will be 3 over 2 plus 6 over 5. The least common denominator here will be 10. This will become 15 over 10 and plus 12 over 10, which is basically just 27 over 10. Last example here, you multiply the whole number to the denominator, you add to the numerator. This will become 5 over 2 plus 5 over 2 plus 11 over 5. So the least common denominator here will be 10. You multiply 2 by 5, 5 by 5, you get 25 over 10 plus 22 over 10. So in result, we add the numerators here, we will get 47 over 10. So basically, adding and subtracting mixed number, we have to apply all the rules we learned in earlier slides, converting it into improper fraction, adding and subtracting with the same denominator, if not converted into same denominator first with unlike denominators. Okay, let's look at the next one, simplifying fractions here. So unlike subtracting with unlike denominators, simplifying fraction, you have to find the greatest common divisor, which is a number that both the numerator and the denominator can divide it by. Let's take a look at the example here, 6 and 8. You find it that 2, you can both divide 6 by 2 and 8 by 2. This will just result in 3 over 4. Let's take a look here. Also, if you can't find the greatest denominator first, you can just divide it by the common divisor you can come up first, and you further simplify with the result you get of that. First, in this case, we see 14 and 22, the greatest common divisor will be 2. You can both divide 14 and 22 by 2. So this will just become 7 over 11. And as we see here, this cannot be further simplified. So this will just result in 7 over 11. In this case here, 8 over 18. As usual, we find it the greatest common divisor will be 2 here. So the numerator divided by 2 is 4, and this will result in 9. And we cannot further simplify these fractions. So this would just result in 4 over 9. This case here, 14 and 28, we can both divide it by 2. So this will just result in, first we can divide by 2 first. This we result in 7 over 14. As we find here, we can also divide it both by 7. So this will just later result in 1/2. If you're smart enough, you'll find first that you can divide 14 by 28. So you divide 14 to 14 and 28 to 28. 28 to 14, 2. So this will just result in 1/2. But if you cannot see that the greatest common divisor, you can just simplify multiple sets. That will also be okay. Multiplying fraction. There are 3 steps here. First, you multiply the numerators and you multiply the denominators, and you simplify the fraction if possible. Here an example of 3 over 4 times 2 over 5 will result. You multiply the denominator and the numerator together, 3 over. This will result in 3 times 2, 4 times 5. It will result in 6 over 20. So you can simplify this fraction here. So you find the greatest common divisor here will be 2 first. So you divide both the numerator and denominator to 2. This will become 3 over 10. Okay, let's take a look at the first example here. So quick tip here. When multiplying fraction, you can actually see the greatest common divisor. You can first, for example here, you simplify the numerator with the other denominator here, and you find the greatest common divisor among them. In this case, 3 and 9, the greatest common divisor will be 3. So this will become 1. This is 3. 10 and 2. It will just be 2. And this will be 2 divided by 2 will be 1. 10 divided by 2 will be just 5. And you multiply the numerators, denominators together, you will result in 1 over 1 times 1 will just becomes 1. 5 times 3 will just becomes 15. So it's 1 over 15. And we cannot further simplify this. Anytime when you see the numerator is 1, you cannot further simplify this because the greatest common divisor among the numerator will just be 1. And that will result in nothing. Let's take a look here. You can first simplify the numerator with the other denominator 1 and 5. You cannot further simplify this because you see the numerator is 1 here. 3 and 3 can actually simplify this. This will become the greatest common divisor will be 3. So divide 3 by both sides will result in 1 over 1 times 1 over 5, which just becomes 1 over 5. This you can rewrite as 1. Okay, take a look here. First, you can find the greatest common divisor here between 4 and 8 will be 4. So this will become 1. This will becomes 2. 5 and 5 obviously will just becomes 5. The greatest common the LCD where you said the GCD will just becomes 5. So this is 1. This is 1. This will 1 times 1 is 1, 1 times 2 is just 2, so this is just 1/2. Here you see the 7 is 14, the GCD will just be 7, so divide by 7 by 7, 14 by 7 will just becomes 2, and here it will becomes 1, 5, this would become 1 over 10. Dividing fractions here. So this is when dividing fraction, you want to convert it into multiply. So basically, you just multiply by the reciprocal of the second fraction, simplify if necessary. The reciprocal, it just simply means you flip the numerator and denominator of the second fraction. So in this case, 1 over 4 divided by 5 over 4, this will become 1 over 4 times the reciprocal of 5 over 4. Which you flip it just becomes 4 over 5. You simplify 4 and 4 out, this is just 1 over 5. Okay, let's take a look at the first example here today. When you see 3 and 9, you probably ask if I can simplify this first. You cannot because you have to multiply the reciprocal first. So this will become 4 over 3 times the reciprocal, which is, you flip it, which is just 5 over 9. 5 over 9. You times the numerator and denominator together, so this will becomes 20 over 27. So a quick tip here, I know I cannot simplify this because when you're looking at the multiplying with the, if you cannot simplify this and this and this and this, like the denominator to the numerator to the other numerator, you know that the result will be the simplest form here. This case here, 7 over 2, this will just multiply 16 over 7. You times the reciprocal, you flip it, and we can simplify this into 1, this into 8. So 7 times 8 will equals to 56 over 17. In this case here, you flip it, 20 over 9 times 24 over 8. This will becomes, you can simplify this actually. Simplify by 4, this will becomes 2, this will becomes 5, and you simplify this by 3, this will becomes 3, and this will becomes 8. You multiply the numerator and denominator, you will get 6 over 4d. Okay, let's take a look at the summary here. So this is basically all the fraction operation we've seen today. Subtracting, adding, the multiplying, dividing, and also we see how to convert improper fraction to mixed number, or mixed number to improper fraction, how to simplify different types of fraction, and adding fraction with the different denominators, which you basically find converted into the same denominator first. Let's take a look at the challenging problem today. This might seem terrifying at first, but as we discuss in the first topic here today, you can see the line here as the divide sign, so we can basically convert this into 1 divided by 2 plus 1 1/3 plus 1 divided by 2 minus 1/3. So in this case here, you have to do the operation inside bracket first. This will becomes you convert them with the same denominator. This will become 6 over 3 plus 1 over 3 plus 1 divided by 2 minus this will become 6 over 3 and 1 over 3. So you convert this into the same denominator, and then you add them together. 1 divided by You add the numerators with the same denominators. This will become 7 over 3 plus 1 divided by 7 over 7. This will minus, so you minus the subtract the numerators. This will become 5 over 3. So in this case, you times the reciprocal of the second fraction. This will become 1 times 3 over 7 plus 1 times 5 over 3. So 1 times itself is just basically the number itself. So this will become 3 over 7 plus 3 over 5. Again, you convert them with the same denominator here. So the same that the least the LCD will be 35 here. This will be 35. You multiply 3 by 5 is 15. You multiply 7 by 5 will be 37. So you multiply the numerator by 72, which is 21. And you add the numerators with the same denominator. It will just result in 36 over 35. You can convert this into a mixed number with 1 over 1, 1 and 1 over 35. So that's just basically it. As you see here, we just first convert it into divides, and you just basically go on. Okay, that's the end of the lesson here. In the next, go for the next lesson. We'll start introduction to geometry here. Thank you for listening today, and I'll see you in the next lesson.